Okay, so we're going to look at the lattice enthalpy of dissociation for calcium iodide. So calcium is in group 2 and it will have a +2 charge. Iodine is in group 7 and it will have a minus charge. So calcium iodide is CaI2. And if we do the equation for this, then calcium is a solid and it will react with iodine, and iodine in its standard state is a solid, and it will give calcium iodide as a solid. Okay, so if we draw the enthalpy equation for this, so this would be calcium in its solid state plus iodine in its solid state, and it would give us calcium iodide in its solid state. So we know this. So if I then do my transformations just on the metal, I'm going to turn calcium into a gas. I'm then going to take 1 electron off calcium and ionize it. I'm then going to take a second electron off calcium and ionize it. Okay, now I'm going to do the next transformation on the iodine. I'm just going to use a different colour so we can actually see what I'm doing. So the iodine stays as a solid, stays as a solid, and stays as a solid. Now the transformation I'm going to do on iodine here is I'm going to turn it into a gas. So I2 gas. And then what I'm going to do is I'm going to break the iodine bond and I'm going to make iodine atoms. Okay, the calcium can stay as it is, Ca2 plus as a gas, and 2 electrons, Ca2 plus as a gas, and 2 electrons, and I'm just going to rule that off. Okay, so now what's going to happen is the iodine is going to pick up those electrons, and just look, there's 2 iodines, 2 electrons, so they're going to pick up, that's going to be quite exothermic. Yes, exothermic. So I've got 2 iodine ions now, and I've got my calcium 2 plus, and then they're going to come together, and that's my lattice enthalpy of dissociation, lattice enthalpy of formation. Right, so let's put some figures on here. So the question is, here we go, number 5. Calculate the first electron affinity of iodine. So that's this one here. We're going to have to do that. Given that the lattice enthalpy of dissociation, okay, so it's giving me that is plus 2054. So we know if we're going to come this way, it must be minus 2054. So I'm going to come this way, it's 2054. It won't, as long as you treat it, as long as this is the only one we look at. 054. Okay. And its enthalpy of formation, this is minus 535. Okay, so we can't see that very well. I'll choose a different colour. I've got red, so minus 535 minus 2054. Okay, so this is atomization of calcium plus 193. This is ionization of calcium plus 590. This is the second ionization of calcium plus 1150. Okay, so now we're on to iodine. So to take the solid to a gas, we are looking at that's not atomization. So if we go okay, so I have taken this solid to a gas, so basically I've sublimed it, but actually, because this is a non-metal, I would turn it from its standard state to its atoms like this, and the the bond breaking here, or atomization, is to create 1 mole of atoms, and as you can see I've created 2 moles of atoms, so to go from here to here is plus 107 times 2. Okay, so this just goes to show that even teachers can make a mistake. So going from solid to gas for iodine, and we're going to go from the solid to the atoms, so this is the atomization. Okay, so we've got to find this first ionization, first electron affinity, so that's the electron affinity that we're going to find, and everything else we have got. So we can set up our equation. We will be going this route, so this route here is the same as going around this route here. So I'm going to set up this equation. So we've got minus 535 equals, and I've got plus 193 plus 590 plus 1150 plus 2 times 107, and we've not just got 1 electron affinity, we've got 2 electron affinities, so I'm going to put 2 EA there because I've got 2 iodine atoms going to 2 iodide ions, and then I'm going with this arrow, so minus 2054. So all I need to do is simplify these numbers and then I can rearrange. Okay, so I've simplified all of these numbers, and minus 535 equals 93 plus 2 electron affinities. So if I just rearrange the equation, so minus 535 minus 93 equals 2 electron affinities. And I can do those maths. So this is minus 628 equals 2 electron affinities. So the first electron affinity for iodine is minus 628 divided by 2, which equals minus 314 kilojoules per mole.